One of the wildest things you'll notice about trucks is that they can have gearboxes with up to 18 speeds, while a regular car usually has just 9 if it's automatic, or maybe up to 6 in a manual. But why do trucks need so many gears? And what makes all those gears necessary? To answer that, we need to go deep into how truck engines work, and why a regular transmission just wouldn't cut it. Let's start with a simple truth. Truck engines don't work like car engines. While a car engine can operate comfortably across a wide range of RPMs, say from 1,000 up to 6,000, a truck engine only works efficiently in a much narrower band, usually between 1,000 and 1,600 RPM. That's its sweet spot. That's where it delivers maximum torque, the pulling force that keeps 40 tons of cargo moving uphill. But keeping the engine in that range is not easy. Roads go up and down, loads vary, and even the wind can mess with the balance. So the only way to keep the engine in that optimal power band is to give the driver more gears to work with. Think of it like climbing a ladder with smaller steps. The more gears there are, the smoother the climb, and the easier it is to keep the engine doing exactly what it's meant to do, without overworking it or letting it stall. Here's what would happen without enough gears. Imagine you're going uphill. The truck is in a mid-range gear. The RPMs are rising and torque is starting to drop. Time to shift up. But if the next gear is too far apart, the RPMs could fall below 1,000. And now the engine doesn't have enough force to keep pulling. It loses power. The truck slows down. In the worst cases, it stalls. On a hill, that's not just inconvenient, it's dangerous. That's exactly why multi-gear transmissions exist in heavy trucks. They let drivers make smaller, more precise shifts, so the engine always stays in its efficient zone. More gears mean better control, especially in extreme situations, steep climbs, long descents, or carrying heavy loads on winding roads. And here's something most people don't realize. Truck transmissions aren't just about getting the right speed. They're about protecting the engine, saving fuel, and keeping the driver in control, even when everything else is working against them. But that's only the beginning, because these 18-speed systems aren't made of just one gearbox. They're built using a clever combo of multiple layers, including something called a range splitter and a gear multiplier. How does a 5-gear base suddenly turn into 18 usable speeds? Now, here's where things get really interesting. You might think a truck with 18 gears has 18 separate gear positions on the shift stick, but that's not quite how it works. In fact, most heavy-duty trucks are built around a much smaller core gearbox, often with just 5 or 6 main gears. The rest? They come from multipliers and splitters layered into the transmission system. Let's break it down. Imagine a base transmission with 5 main gears. On its own, that's pretty basic, but then you add a range selector, which essentially gives you 2 versions of those 5 gears, a low range and a high range. Now you've got 10. Still not enough for the kind of weight and control these trucks need. So here's where the magic happens. Introduce a gear splitter, a tool that divides each gear into 2 sub-gears, often called low and high. Now, each of your original 5 gears doesn't just become 2 gears. They become 4 when combined with range and split options. That's how you go from 5 to 10, that to 15, and finally up to 18, depending on how the transmission is set up. And for the driver, this means shifting isn't just about pushing a lever forward or backward. It involves toggling switches, moving a splitter, flipping a range selector, sometimes all in a matter of seconds, while hauling tens of thousands of pounds down a highway. It's not just driving, it's multitasking with massive mechanical consequences. And no, this isn't some outdated system. It's still the standard in long-haul trucking all across the Americas. Why? Because it works. It gives the driver full control over the power delivery of the engine, especially when facing hills, heavy loads, poor traction, or unpredictable weather. In fact, experienced drivers will tell you that these systems aren't just efficient, they're a matter of pride. Mastering them means knowing your truck inside and out, understanding how it breathes, when it struggles, and how to keep it perfectly balanced mile after mile. But if all this sounds complicated, it's because it is. And things only get more intense when you realize what happens if you choose the wrong gear at the wrong time. Because when you're rolling down a steep descent with 40 tons behind you, missing a shift isn't just a rookie mistake, it's a potential disaster. So what actually happens when you downshift or upshift in a truck like this? And how does it affect fuel, braking, and engine life? That's where we're headed next. Shifting gears in a heavy truck isn't just about adjusting speed. It's about managing energy, massive amounts of it. See, when a truck driver shifts to a lower gear, they're not just slowing down, they're increasing the torque, or rotational force, delivered to the wheels. That's exactly what you need when hauling uphill, starting from a stop or trying to move a fully loaded rig without burning out the clutch. Let's say you drop from 5th gear to 4th. The wheels now turn a bit slower, but the engine revs higher, delivering more torque. This makes the truck feel stronger, better able to pull weight. It's like switching from a jog to a power walk with better footing. Now reverse that. Upshifting from 4th to 5th means less torque, but more speed. Ideal for cruising once you've already built up momentum. In this higher gear, the engine doesn't need to work as hard to maintain speed. That means better fuel efficiency and less engine wear. But here's the catch. Get it wrong and things unravel fast. If a driver shifts too early into a high gear, they might drop the RPMs too low, falling outside the power band. That's when the engine can't generate enough force, and the whole truck bogs down. If it happens while going uphill, the truck might slow to a crawl or stall completely. On the flip side, shift too late and the engine runs too hot, over-revving beyond its ideal range. More heat, more wear, more stress. Over time, that can mean serious damage to both the engine and the transmission. This delicate dance is why experienced drivers seem to have a sixth sense for when to shift. They listen to the engine, not just the sound, but the feel. Every vibration, every tug on the drivetrain tells them when it's time to move up or down a gear. And the stakes are higher than you might think, because when a fully loaded truck is descending a long hill, gravity becomes the real enemy. Relying only on brakes to control speed is a recipe for disaster. They can overheat, lose effectiveness, or even fail completely. That's why trucks use something else: engine braking. And here's where gear control becomes life-saving. By selecting the right lower gear, the driver can make the engine resist the truck's motion, using compression to slow the vehicle down without overloading the brakes. It's called Jake braking, or using a compression release engine brake, and it only works when you're in the proper gear. Too high and the effect is weak. Too low and the engine can over-rev dangerously. In short, having the right gear at the right time isn't just about performance, it's about safety, fuel, and the long-term health of the entire machine. So now you might be thinking, why not just let the truck shift itself? Automatic transmissions have been around for years. So why do many truckers still prefer doing it manually? At first glance, automating the shifting process in a truck sounds like a no-brainer. After all, modern cars have done it, and in city traffic or long-distance hauls, having a computer handle the gears could make life easier, right? Well, it depends who you ask. For newer drivers, automatic transmissions are a blessing. No need to worry about matching engine speed, no missed gears, no mental juggling act at every intersection. Just press the pedal and go. And that's exactly why many logistics companies have started transitioning their fleets to automatic or automated manual transmissions, AMTs. They simplify training, they reduce wear and tear caused by driver error, and most importantly, they open the door to more drivers at a time when the industry is struggling with shortages. But for veteran truckers, the automatic option isn't always welcome, because manual shifting offers something computers can't match: total control. Let's say you're approaching a steep grade with a heavy load and icy roads. An experienced driver in a manual truck can select the exact gear they need, not just for climbing, but for safely descending on the other side using engine braking. In an automatic, the computer might hesitate or shift at the wrong moment, especially if it's not tuned for that specific terrain or weight. And then there's the mechanical side. Manual transmissions are generally cheaper to manufacture, easier to repair, and more durable, as long as the driver knows what they're doing. Fewer electronic components means fewer failure points. In remote areas, that can be the difference between a quick roadside fix and a $1,000 tow to the nearest service center. Fuel efficiency is another factor. While modern automatics have improved a lot, many veteran drivers still swear by manuals for getting the most miles per gallon. When every drop of diesel counts, the ability to shift based on instinct and terrain can squeeze out extra efficiency that computers might overlook. Of course, manual gearboxes aren't perfect. They're physically demanding. In stop-and-go traffic or on mountain routes, the constant shifting wears down not just the clutch, but the driver too. Fatigue becomes a real safety issue, And if the driver is inexperienced or poorly trained, a manual transmission can lead to faster wear, more breakdowns, and dangerous mistakes on the road. That's the trade-off. Control versus comfort, tradition versus technology. It's also why the trucking world is slowly evolving, not by replacing manual transmissions entirely, but by merging the best of both systems. Because hidden in between the extremes, there's something else: automated manual transmissions. And this hybrid approach might just be the future of trucking. We'll explore how that works, and why it might solve the biggest pain point in the entire industry, right after this. So far, we've talked about manual transmissions and their unmatched precision. We've looked at automatics and their ease of use, but somewhere in the middle, there's a rising solution that's quietly taking over the industry: the automated manual transmission, or AMT. Now, let's be clear, this isn't just an automatic transmission in disguise. An AMT is actually based on the same mechanical structure as a manual gearbox. It still uses clutches, gears, and the same basic logic truckers are used to. The only difference? The computer handles the shifting. That means you get the durability and efficiency of a manual system, but without needing the driver to physically shift gears every few seconds. For new drivers, it makes learning far easier. For companies, it reduces training time and maintenance costs. And for experienced truckers, AMTs still allow for manual override, giving them full control when they need it, like on icy roads, steep descents, or in tight city turns. But perhaps most importantly, AMTs are helping the industry face its biggest challenge: the driver shortage. With fewer young people entering trucking and older drivers retiring, the need for accessible, less physically demanding systems is urgent. In that context, AMTs are more than a convenience. They're a survival tool for the logistics world. It's no coincidence that in places like Europe, AMTs are already dominant. Narrow streets, tight schedules, and aging driver populations have pushed adoption faster. And in countries like Australia or Japan, where extreme terrain is common, the ability to blend control with automation has made AMTs a practical must-have. Of course, not everyone is convinced. Some truckers still see AMTs as taking the skill and the soul out of the job. They argue that when things go wrong, only a driver who truly understands the mechanics of the gearbox will know what to do. And in certain situations, they might be right. But as technology advances, the gap is closing fast. Modern AMTs are getting smarter, faster, and more adaptable. They learn from terrain. They anticipate driver behavior. They protect engines and maximize fuel use better than many humans can. Which brings us back to the big question: why do trucks have so many gears? The short answer: because they need them. Not for speed, not for style, but to handle massive loads, protect the engine, and survive the brutal demands of long-distance driving. Each gear is a tool, a precision instrument in the hands or under the foot of someone moving the economy one highway at a time. And whether it's 18 gears on a stick or a smart transmission doing the thinking for you, the goal is the same: power, efficiency, and control. So next time you pass a truck roaring up a hill or gliding down a mountain, just remember there's a whole world of decisions happening under that cab. And every gear shift, whether manual or automatic, is part of a much bigger machine. So the next time you spot a semi-truck shifting gears over and over again, you'll know exactly why. It's not overkill, it's precision. 18 gears might sound excessive until you realize each one helps keep tens of thousands of pounds under control mile after mile. Whether it's an old-school manual or a high-tech AMT, the real goal has always been the same: making something massive move, efficiently, safely, and with total control. If you found this breakdown interesting, don't forget to like the video. It really helps the channel grow. And if you've ever driven one of these beasts, or are just curious about what it's like behind the wheel, drop a comment below. We'd love to hear your story. And hey, if you're into the engineering side of everyday machines, we've got more deep dives coming. Subscribe so you don't miss what's next. Thanks for watching, and we'll see you on the next haul.